Hello, I'll be talking about measuring angles and different ways to measure angles when we're dealing with, geometry and shapes like that. So we're going to start off with the unit circle. Now, the unit circle goes from 0 degrees all the way to 360 degrees, or 0 radians to 2 pi radians. Now, being the unit circle, you have, goes around like so, starting at 0 degrees or 0 radians. Here, this is 90 degrees or pi over 2. This is 180 degrees, or pi. This is 270 degrees, or 3 pi over 2. Now, you can also break this up even further. You can go to pi over 6, or 30 degrees, pi over 4, and that would be 45 degrees, and pi over 3, which is 60 degrees. You can continue that all the way around with these same fractions around the entire thing. Now, when you're measuring an angle, typically you'll have 2 rays. We can have A and B, and the angle between them will be like that. Now it can also be going around that side. And the angles don't always have to be positive, they can also be negative. So, for instance, if you have your first ray, or line segment, and then it goes like that, that angle could be negative if we have our XY plane. Alright, next we're going to be talking about right-angled trigonometry. And to do this, it's when you use trig functions to find either an angle or a side of a right triangle. Now, we're going to be in reference to this triangle, which has angle theta, sides A and B, and hypotenuse C. So now, when you're measuring the sine of a right triangle, you're going to have the opposite over the hypotenuse. So the side opposite of theta would be B over C. When you're doing cosine, it is the adjacent over the hypotenuse. So you'll have A over C. And tangent, you're going to have the opposite over the adjacent. So you will have B over A. Now this can be helpful when you're trying to find the side of a triangle or the angle given. So if you're trying to find a side and you know the angle and the hypotenuse, you can have sine of theta equals B over C. Now we know the sine and we know C, but we don't know B. So we are just going to multiply both sides by C. So we're going to have C times the sine of theta equals B. And then we would plug in our values and then we would solve for B. If you're trying to find the angle and you know 2 sides, we can use cosine for this one. So we have cosine of theta equals A over C. You're then going to take the inverse cosine of both sides. Theta equals cosine to the -1, and that stands for the inverse of A over C. And that is basic right angle trigonometry.
Hello, we are going to go over trigonometric functions and what they look like on graphs and what are some key points we want to look out for on the unit circle that changes the way that these graphs look like. So let's start off with the basics, which is the sine, cosine, and tangent relationships of a triangle. As you may look over at these unit circle, you can see as we go around the unit circle on a counterclockwise, we form these different kinds of triangles that have to do with the horizontal line here. So if we were going to describe what the sine value of pi over 6 is, we'd look at this hypotenuse right here and the x value right here, which is currently unknown, and the y value right here. So let's go over what sine means. Sine on a triangle is the opposite side over the hypotenuse. The cosine is the relationship between the adjacent side and the hypotenuse. And the tangent relationship is the opposite side of the angle and the adjacent side of the angle. Now, some key points on a unit circle to look out for are 0 degrees or 0 radians, 90 degrees or pi over 2 radians, pi radians or 180 degrees, 270 degrees or 3 pi over 2 radians, and 2 pi radians or 360 degrees. Now what we want to look at is, so let's say we have a cosine value. Well, each of these lines is going to be 1 radius away from the origin. Now, if we were going to say, what is the sine value of 0 degrees, we'd look at, so the radius would be 1, and the x value is going to be 1 as well. So the adjacent, which is the x value, is going to be 1, and it's going to be over 1 because that is what the hypotenuse value of that line is. Let's try a different example. So here is pi over 2. Let's find the cosine of pi over 2. Well, we want to look at the x value, which is clearly 0, and we will put it over the hypotenuse, which is always going to be 1, because each of the radiuses, or radii, I should say, are 1. So 0 over 1 equals 0. So the cosine of pi over 2 is 0. And similarly, as you go over to this side, this value for cosine is going to be the same as this side for cosine, because they're equally, as an absolute value, the same value, except this side is going to be negative for all cosine values. The reason why is this is in the negative x direction. As you can see now, is that cosine is very closely related to what the x values are. So if the x value is negative, cosine is going to be negative, and if cosine, or if x is positive, cosine is going to be positive, which would be this side. For sine, it's going to be a little different, but pretty close. So sine is going to be all the y values, So if you're going to look at the y value, for instance, of 0 degrees, that's going to be 0 over the radius, which is 1. So that's going to be 0 because there's no y value here. Now if we want to do pi over 2, there is a y value of 1 over the radius 1, which is going to give us a value of 1. And as you go over to this side, it's going to be 0 because the y value here compared to the origin is 0. And as you go down here, this is going to be negative 1 because it is negative 1 units down over the 1 unit radius. Now if you want to look at the trends of the various different trigonometric graphs, here you can see same thing going on here. So let's assume this is 0, pi over 2, and pi. As you can see, when sine is 0, which is right here, the y value is 0, which is also going to give it a value of 0. Now let's say the x value is pi over 2. So let's go to pi over 2 and look at the y value, which is 1. And 1 over 1 is going to give us a value of 1. And as you go back over, as we said, pi is going to have a 0 y value, which is going to give us 0 again. So the sine graph is going to oscillate like this as a pattern. And it's very similar to cosine, but it's just shifted a little bit over to the left or the right, depending on which way you want to look at it. So for cosine, let's say that the x value is 0. The x value is going to be 1. So 1 over 1 is going to give you a value of 1. Pi over 2 is going to give you a value of 0 for x. So 0 over 1 is going to give you 0. And pi right here, is a x value of negative 1, which is going to be negative 1 over the 1 unit for the radius, which is going to be negative 1. So I hope you can see the different trends that are happening between the sine and the cosine values. Obviously, tangent is just going to kind of compile this. As you can see, if you look at the unit circle, you can determine what kind of values you're going to get from different radians. It's just a little bit different. So are these inverse, not inverse, but cosecant is just the reciprocal of sine. Secant is a reciprocal of cosecant, and so is cotangent. So they just look a little different. They have just different values because you can't have zeros on the denominators, so that's why you might see these asymptotes right about here. So obviously you can tell where cosecant might not be able to have a value because you'll get a 0 on the denominator. So I hope this helps with all your trigonometric questions, and thanks for watching.
For fundamental trig identities, there are 4 main categories: reciprocal identities, quotient identities, Pythagorean identities, and negative angle identities. First, I will go through the reciprocal identities. The reciprocal identities are the reciprocal of another trig function, such as cosecant is the reciprocal of sine. So the 6 main reciprocal identities are sine theta equals 1 over cosecant theta, cosine theta equals 1 over secant theta, tan theta equals 1 over cotangent theta, cosecant theta equals 1 over sine theta, secant theta equals 1 over cosine theta, and cotangent theta equals 1 over tangent theta. Second, we'll look at the quotient identities. These trig identities equal a trig function divided by another trig function. So that includes tangent theta equals sine theta over cosine theta. The next one is cotangent theta equals cosine over sine theta. So interestingly, this is the opposite of tangent theta, and this is because cotangent theta is the reciprocal of tangent theta. Next, we'll look at the Pythagorean identities. These equations are derived using a triangle and the Pythagorean theorem. These equations are often used in calculus in the trig sub method for finding integrals. So, the main three are sine squared theta plus cosine squared theta equals 1. Seen here. 1 plus tan theta equals secant theta. Seen here. And 1 plus cotangent squared theta equals cosecant squared theta. The final set of trig identities are the negative angle identities, sometimes called the even-odd identities. Like with the Pythagorean identities, these are used in calculus in trig sub. So there are 6 main ones, and that is the sine of negative x equals negative sine x, cosine negative x equals cosine x, tan negative x equals negative tan x, cosecant negative x equals negative cosecant x, secant negative x equals secant x, cotangent negative x equals negative cotangent x. So the way that one works is you're taking the negative from the inside and bringing it to the outside. So they're equivalent. Next, we'll look at the law of sines and the law of cosines. These equations are used to find features of a triangle. These laws apply only to right triangles. So first, we're going to look at the law of sines. But before we get to that, I'm going to explain a little what sine does. So sine of theta, seen here, equals the opposite side over the hypotenuse. So, say we're taking sine of angle C here. That would be the opposite side, sine C, divided by the hypotenuse, side A. The hypotenuse is the longest side of the triangle. It's also the side opposite of the right angle. So, from that, we have the law of sines, seen here. The law of sines states that sine of angle A over the opposite side of the angle equals sine of angle B over the opposite side of the angle, which is side B, and sine of angle C equals the opposite side to that angle, which is side C. So we can use this to solve for a feature we'd like to find, like angle A or side A, for example. And what we do with that is we just rearrange, solving for the part we need to find. Similar to this, we have the law of cosines, seen here. The law of cosines is based on cosine, which is seen here. Cosine of theta equals the adjacent side over the hypotenuse. So say we're looking at angle C again, here. That would be the adjacent side, side B, over the hypotenuse, side A. Now, the way this law works is the hypotenuse squared side equals side B squared, which is the larger of the two sides, but not the hypotenuse, plus side C, the smaller of the two, squared, minus 2 of B times side C, and that's multiplied by cosine of the angle of the side we're looking for, angle A. Now for the others, it's very similar. You're just rearranging the values. So pretty simple couple rules, and they're pretty helpful too. You solve for sides, and we use a lot of that stuff in engineering, and I'm sure I'll use it a lot in the future.
Now we're going to go over the addition and subtraction, double angle, and half angle formulas for trigonometry. So first we'll go over the addition and subtraction formulas. These are very useful when trying to solve trigonometric equations. And it seems like there's a lot, but there's actually quite a few ways to memorize them for use later on. So for the sine ones, I like to remember them as you have the sine and you have the cosine, so the sine of x and the cosine of y, plus the opposite, so the sine of y plus the cosine of x. So if you have plus, you have plus. So if you have a plus over here, you have a plus over here. And the exact same is for the subtraction. So if you have a minus over here, you also have a minus over here. So sine is the same. Sine is same. Now, if you have cosine, cosine is a little different. You still have cosine of x, cosine of y, sine of x, sine of y. So you have, instead of opposites, like over here, you have the same ones over here. And then you have a plus sign over here, but you have a opposite minus sign over here. And then exact same thing for this. You have a minus, you have a plus, and then you have these two are the same, and these two are the same with sine. So cosine equals different. Okay, now the tangent is a little different. So you've got the tangent of x plus the tangent of y if it's addition over 1 minus the tangent x, tangent y. Now if it's minus, like over here, you've got the signs are flipped. So this is a minus, and this right here is a plus. So now we're going to do a little example just to make sure that this works. So we'll start with the cosine. Let me get that out. So we're going to do the cosine of 90 degrees. So first, we're going to break that up. So this will be the cosine of 30 degrees plus 60 degrees. And then we have it in the form where we could use this equation right here, the cosine x plus y. So this will turn into the cosine 30 degrees, cosine 60 degrees, minus sine 30 degrees, sine 60 degrees. And then we could simplify that, so that'll be square root of 3 over 2 times 1/2 minus 1/2 times 3 over 2. So these are the same, they're subtracting, so that equals 0. And we already know that the cosine of 90 degrees is 0, so it checks out. So let's get this out of our way. And then we could do another example of the addition and subtraction formulas, but this time with sine of 90 degrees. So sine 90 degrees is broken down the same way. So we have sine 30 plus 60. And then we'll write it out. So cosine is different from sine. So this time we're going to be doing sine 30 degrees, cosine 60 degrees. And then we will do addition because sine is the same. So we have that plus, we're going to have that plus right there. And then we're going to have sine of y now. So we're going to have that 60 degrees. And then flip for the cosine too. So cosine 30 degrees. And then let's simplify that. So this is 1/2. And then this is also, the cosine of 60 is also 1/2. And then we add that to the sine of 60, which is 3/4 times, sorry, my bad. We are going to make that square root of 3/2 times square root of 3/2, which should simplify to 3/4, and this should simplify to 1/4. 1/4 plus 3/4 equals 1, which we know the sine of 90 degrees is 1. So that checks out. So now we are going to go over the double angle formulas. A lot less memorization for these, but there's not as much of a system to remember it. So the sine of 2x, you take that 2 out. So the 2 is going to be out. And then you have sine x times cosine x. So pretty simple. Now for the cosine of 2x, it's a little different. So you could turn it into a bunch of different things. You could either make it the cosine squared of x minus sine square of x. This one is particularly useful in a lot of solving problems. Or, similar to what you did up here, you could shove that 2 out. You could take the 2 out, cosine square x, and then subtract 1. And then additionally, you could have 1 minus 2 sine squared x. Tangent is different. You have 2 tangent x over 1 minus tangent squared x for the tangent of 2x. Now we're going to do an example with this. So if we were given cosine theta is equal to 3/5. We want to find sine of 2 theta. So using this, sine 2 theta, we know is equal to 2 times sine theta cosine theta. So that is going to turn into 2 times 4/5 times 3/5. And that ultimately simplifies to 24 over 25. So there's our answer. So now let's do a couple things with the half angle formulas. So we've got sine squared of x is equal to 1 over 2x over 2. 1 minus cosine 2x over 2. Sine x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. Again, so most of these, except for the tangent, divide by 2. So cosine squared is similar to sine squared, except you flip the sign. So you have a plus instead of a minus right here. So cosine 2x over 2. Cosine x over 2 is plus or minus the square root of 1 plus cosine x over 2. So very similar to sine, you just flip that little sign right there. And then tangent is a little funky, but it makes sense given trigonometry. So tangent is sine over cosine. So you take your sine, one right here at the top of the sine, and then you take that top of the cosine and you do it. So this essentially is sine over cosine. So that's a good way to remember the tangent if you only remember the sine of x over 2 and the cosine x over 2. So let's do an example. So given the same angle we've got before, given cosine theta equals 3 over 5, we are going to instead find the cosine 1/2 theta. So here, cosine theta over 2 is equal to plus or minus square root of 1 plus cosine of x, or theta, over 2. So that's going to, for us, be equal to 1 plus 3/5 over 2. Tuck that all into a square root. And that simplifies to 8 over 10. Square root of 8 over 10, which simplifies further to 4/5, which then becomes 2 over square root of 5, which can also be written as 2 square root of 5 over 5. And that's everything for our half angle formulas, our double angle formulas, and our addition and subtraction formulas. Thanks for watching.